Good evening, students. So today we'll talk about calendars. A very interesting topic from all the exams perspective. You'll generally find at least one to max of 5 questions in almost all the exams reasoning section. So let's move ahead. The basic definitions. What do I mean by a normal year? Which year is called to be a normal year? A year which has 365 days? Yes, of course. But how do I check whether the given year is a normal year or it's not a normal year? So what do we call the year which is not a normal year? A leap year. So we have two kinds of years, a normal year and a leap year. A leap year will always have 366 days. So February will be having 29 days. Yeah. Now how do I check whether a given year is a leap year or it's a normal year? The basic rules which we have studied since childhood. If the number is divisible by 4, we call it a leap year. If the number is not divisible by 4, it's not a leap year, it's a normal year. So for example, 1996. Let's check if the number is divisible by 4. I assume each one of you remembers the divisibility rules. So last two digits has to be completely divisible by 4. So is 96 divisible by 4? Yes, it is. So that means, can I say it's a leap year? Of course. So similarly, if I go ahead, 2000, if I divide it by 4, is 2000 divisible by 4? Of course. So that means, can I say it's a leap year? Yes, I can. 1700 divided by 4. Is it divisible? Last two zeros? Yes, it is divisible. But can I say it's a leap year? No, I cannot. Now, so that means there is a difference to the rule which we are assuming. So write it down. The rule is, for an year to be called as a leap year, it should be divisible by 4, but for a century completion year. That means the year ending with two zeros. For that year to be called as a leap year, it should be divisible by 400. So 1700, let me divide it by 400. Is it divisible by 400? No, it's not. Right. Is it divisible? No. I hope you understand the meaning of the word divisible. That means leaving a remainder of 0. Completely divisible. Is it divisible? No, it is not completely divisible. So the year is not a leap year. Is that okay? Clear to everyone? So this year is not a leap year. For a century completion year to be called as a leap year, it should be divisible by 400. Fair enough. So that means, now how do I use all these facts to answer the question? So let me write down a simple statement. If 17th of March, a particular year, let's say 1549, is given to be a Tuesday, I need to find out what is the day on, let's say 17th of March, the next year, 1550. Can I count it on fingers? Of course I'll not. A year has crossed by, the date is same, so that means 1549 to 1550, a year has crossed by. Either of the years 49 or 50 is not a leap year, so we need not to worry about it. So a year has crossed by. How do I check? I assume everyone understands a week has 7 days, so that means the same day gets repeated after 7 days. So if today is a Wednesday, I'll have the next Wednesday after 7 days. So that means whatever the gap is, here the gap is 365. I need to divide that gap by 7 and find out the remainder of this division. Yes, is that okay? So let's find out. 7 5s are 35, 7 1, 7 2s are 14. So what is the remainder? 1. Now the concept starts. Remember, now this 1, the remainder, whatever is the gap between the two given dates, after dividing that gap by 7, whatever the remainder you get, that remainder is known as odd days. In aptitude terms, we call this as odd days. Now, what do I mean by odd days? The days which will be shifted ahead from this particular day. But mathematically, you need to remember the word odd days. So there can be a direct question, how many odd days are there from this to this? So gap divided by 7 and the remainder, right? So now what do I mean by one odd day here? Because the previous year 17th March was a Tuesday, so 1550 it is going to be a Wednesday. Is that okay? Clear to everyone? Further taking on the discussion, let me write down one more example now. So if I say 17th of March 1647 is a Thursday. What is the day on 17th March 1648? Can I apply the similar logic? There is a year gap, so that means one day has to be shifted. So the next day is Friday. No, I cannot. Remember, bache. Now the next year which you have with you here is what? What is the next year you have? The next year we have is a leap year. 1648 happens to be a leap year, right? So if 1648 is a leap year, 1648 is a leap year. Am I crossing the February of this leap year from the given dates? Yes, I am. Look, am I crossing the February? Yes. 1647 is a Thursday. 1648, which is a leap year, from moving from 17th March of 1647 to 17th March of 1648, am I crossing the February of that leap year 48? Yes, I am crossing. So when you cross a century, when you cross the leap year February, that means I have 360 days, 366 days in between. So 366 divided by 7 gives me how much? 2. So that means whenever I cross a leap year, I have 2 odd days. Is that okay? So that means 17th March 1748 will be what? Thursday plus 2. So it is going to be a Saturday. Is that clear, bache? Right? So 17th March 1648 is going to be a Saturday. Remember, whenever we cross a normal year, whenever you cross a normal year, you have one odd day, and whenever I cross a leap year, I have 2 odd days. That's the basic fundamental of calendars. Going further, obviously the discussion will not be limited to a gap of 1 year or 2 years. The gap can be for 100 years also. If I talk about the first 100 years, the day from the day the calendars was devised, that means 0001 to 0100, right? I am talking about these 100 years. So 100, was that a leap year? No. As we talked about, it is not divisible by 400. So the first 100th year I am saying, right? So how many leap years will be there in between? 0004. That's the first leap year from the day calendars were used. 0016. Likewise, going ahead, 0, yes, 096. 100 is not, right? So how many leap years from 4 to 96? 24 leap years. 100 years, can I say 1 year has 1 odd day, so 100 years will have 100 odd days? So 100 years will have minimum of 100 odd days plus. A leap year will have 2 odd days, but 1 odd day of that leap year is already counted in this 100. So that means the second odd day of that leap year, so that means 24 extra days has to be added. Are you getting it? Why am I adding 24? Because there are 24 leap years, and a leap year has 1 extra odd day, so I am adding that. So this total becomes 124 divided by 7. So I hope you all can divide it orally. So when you divide it by 7, you get 5. So remember, 100 years. I'm saying the first 100 years. So can I generalize for any 100 years? I have to think. If the century which is being crossed, is a leap year century, then it is 6 odd days because I'm not counting 100 here. If the century which is being crossed is a normal year century, That means 5 odd days always. So taking the discussion further, if 100 years has 5 odd days, so can I generalize assuming that the century being crossed is a non-leap year century? So 5 ka double is 10, 10 divided by 7 is 3, so 3 odd days. Similarly, can I say 300 years will have 1 odd day, because 5 3 times becomes 15 divided by 7 gives you 1. The basic underlying assumption in all these three data is the century being crossed is a non-leap year century. If the century being crossed is a leap year century, any of it, because the century, a leap year century comes after every 400 years. So now 400 years, so 5 fours are 20, but now I need to wait and think, because one of the century among these 400 has to be a leap year, and if I am talking about the first 400th year, right, from 0001 to 0400, 400 itself was at a leap year. Yes, so plus 1, 5 fours are 20, plus 1 gives you 21, divided by 7 gives you 0. Very important information, bache, very important information. Calendar repeats itself after every 400 years. Again, I am not saying the vice versa is true, that the calendar only repeats after 400 years. No, it may repeat before that as well. But calendar repeats or has to repeat after 400 years. So just giving an example, if I say 16th March, you might be wondering why I'm taking March again and again. Yes, I hope the intelligent people would have guessed it by now. Anyhow, 16th March 1648, suppose if it is given to be a Monday, so that means 16th March 2048. Are you getting it? Has to be the same day. Why? Because there is a gap of 400 years. The calendar always repeats after 400 years. This fact can be used to answer many other questions. I'll just take quickly one more example. So if I say 16th of April, so let me move from March to April. 1648 is given to be a Tuesday. If I'm taking a random data, so what is the day on 17th of May 1848? Now while you go from 1648 to 1848, the century which is getting crossed is 1700 and 1800, so none of them is a leap year, so that means 200 years. 200 years gap, as we just discussed, right? 200 years gap means how many odd days? 3 odd days. So can I simply say that 16 April 1848, because 16th April 1648 is given to be a Tuesday, so adding 3 to this Tuesday gives you Friday. So this gives you Friday, right? Now I have to go from 16th April to 17th May, because I have already entered that year. Either you go from 16 April to directly to May. So 16 April to 16th May, how many days you cross? 16th April to 16th May, how many days we cross, bache? 30 days, because April is getting crossed, and one extra day, so that means 31. So 31 divided by 7 gives you the remainder as 3. So adding this 3 to Friday gives you what? Monday, right? So I'll take a pause here. That's the first part of calendars. Many more things has to be discussed in calendars, which we'll discuss in our forthcoming classes. Any doubts you have regarding any of these topics, any of these concepts which I have talked today, you can always talk to me on my gtalk ID aptitude.expert@gmail, right? I'm always glad to take any doubts free of cost always. Thank you. Thanks a lot. We'll talk about more in the next session.